What do you mean by rate measure? It is nothing but rate of change of quantities with respect to one variable to the other. Negative symbol denotes the quantity is decreasing and positive denotes the quantity is increasing. Take only positive quantities because y is a distance. So distance is always positive. So even though it is under the square root, you can write it as a positive. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are taking up with the new chapter, Applications of Derivatives. So, in the last sections, we have learned how to derive a particular function in different form. That is, derivative of a function in composite form, parametric form, explicit form, and also we have learned to derive exponential and logarithmic functions also. Also, we have studied the second order derivatives. So, what is the usefulness of learning these derivatives here? So, in this lesson, we are going to study what are the applications of learning derivatives of functions. So, here one of the application is rate measure. So, I have marked here which is a 5-mark question for your examination. There will be one compulsory question from the rate of change of quantities for 5 marks. Now, what are the importance of studying these derivations here? So, here is one of the applications I have taken. Other than this, we have, that is, by learning the derivatives of a function, we can find out whether the function is increasing or decreasing. And other than this, we can also approximate the values. We can find the equation of tangents or slope of tangents or normals. So, normal is a line which is perpendicular line to the tangents. And other than this, we can find the turning points in the curve. That is, we can find the maximum value which is called as maxima and minimum value which is called as minima of a particular curves geometrically. So, these are the wide variety of application which you have in your syllabus in the chapter Application of Derivatives. So, let's start learning them one by them. Now, here is the rate measure. What do you mean by rate measure? It is nothing but rate of change of quantities with respect to one variable to the other. So, suppose when I write a function y is equal to f of x. Here, x is independent variable and y is dependent variable. Thus, rate of change of y with respect to x can be written as rate of change of y with respect to x. So, this is nothing but your dy by dx. Thus, dy by dx is nothing but the derivative of a function. But what does it represent? It always represents the rate of change of y with respect to x. Similarly, if I write dA by dB, what is this dA by dB represent? That is rate of change of quantity A with respect to B here. Similarly, when you apply this to any form of parametric function, what do you mean by parametric function? A function where both x and y variable are expressed in other parameter. Suppose if I take x is equal to some 280 and y is equal to some 4t square. So, here x is equal to 280, x is expressed in terms of t, y is also expressed in terms of t. Then how to find out dy by dx? So, in this case, dy by dx, you already know dy by dx can be written as dy by dt divided by dx by dt. So, this is how you are going to calculate dy by dx, where both y and x are expressed in common parameter. It may be any t or theta, any p, any u, v, anything, but both x and y are expressed with the same parameter, any third parameter. Suppose if I take an example of x is equal to some 4k cube plus 3k and y is equal to some 3 cos square theta. So here what happens? What is the derivative, that is dy by dx, or what is the change in y with respect to x? In this case, dy by dx is purely 0 because there is no link between y and x. They are completely expressed in different parameter. In this case, we can't find out the rate of change of quantity y with respect to x. So along with this, we have some physics applications also. So what is rate of change of distance with respect to time? So usually we denote s as a distance and t as time t. So we know that rate of change of displacement is nothing but ds. Rate of change of time is t. So displacement with respect to time is nothing but your speed. So similarly, velocity v is nothing but, so speed. So rate of change of speed with respect to time. If you take acceleration is dv by dt. That is rate of change of velocity with respect to time. In this case also, in a similar way, we can express many of the physical quantity, that is rate of change of one physical quantity with respect to another. So when it comes under the geometrical section, so consider a circle here with radius r. When r increases, obviously the area of a circle increases. When r decreases, the area of a circle decreases. So how we can express change in area with respect to radius? We can express it as dA by dr. How to derive it? We know that area is nothing but pi r square. So we are deriving with respect to r with respect to r only. So here when you derive it, pi is a constant, r square is 2r, so which is equal to 2 pi r. So change in area with respect to radius is 2 pi r. Similarly, when you consider a cube of length L, so here is a cube. So I'll just consider the length L. So if you take the volume, then volume of a cube is L cube. What is the change of volume with respect to length? That is dV by dL. Here it is 3L square. So this is rate of change of volume with respect to side. Now we come across certain things where we always express the rate of change of quantity with respect to only time. Whenever you express this with the time, then here change in area with respect to time is given as dA by dt some centimeter square per second, because area is always expressed in terms of square unit. It may be centimeter square, feet square or meter square, but it is always expressed with respect to time as per second. Similarly, change in radius with respect to time can be written as dr by dt, change in volume dv by dt. Like this, all quantities can be expressed with respect to time. So this is all about the rate of change of quantity. Now we will take up problems related to rate of change of quantities, which is very simple to understand. So it is very important and compulsory question under the category of 5 marks questions. So let's see the first one. The length x of a rectangle is decreasing at the rate of 5 cm per minute and width y is increasing at the rate of 4 cm per minute. When x is equal to 8 cm and y is equal to 6 cm, find the rate of change of the perimeter, the area of the rectangle. So here rectangle is given. So we know that rectangle has length and breadth here. Suppose if I consider this as rectangle, so length is given and length is expressed in terms of x here, and width is given, that is expressed in terms of y. So we know that opposite sides are equal and parallel in a rectangle. Now what they have given, there is a change in length as well as change in width. So change in length is decreasing. So whenever it is decreasing with respect to time, because it is given as 5 cm per minute, that means there is a change in length with respect to time and it is decreasing. So we will write it as -5 cm per minute. Next they have given width y is increasing at the rate of 4 centimeter per minute. So we write dy by dt is equal to 4 centimeter per minute. Now what they have asked, when x is equal to 8 centimeter and y is equal to 6 centimeter, find, remember here rate of change of perimeter. Perimeter we take it as P. So therefore rate of change of perimeter means dP with respect to time, because each term here is taken with respect to time only. So rate of change of perimeter means we have to calculate dP by dt, and rate of change of area, that is we take it as dA by dt. Now let's find out what is dP by dt and dA by dt. So first we will calculate the perimeter. So perimeter of a rectangle is nothing but adding all the sides. So x plus y, 2x plus 2y will be the perimeter. So therefore here 2x plus 2y. So here let us derive it with respect to t. So p with respect to t, dP by dt, 2 is constant, dx by dt, again 2 is constant, dy by dt. So therefore dP by dt is equal to 2 into minus 5 plus 2 into 4, which is minus 10 plus 8. So therefore dP by dt is equal to minus 2 centimeter per minute. So here minus indicates the perimeter is decreasing 2 centimeter per minute. So for 1 minute it is decreasing 2 centimeter, that is negative. Now let us calculate the area. So area of a rectangle is nothing but length into breadth. So here length is x, breadth is y. Now let us differentiate with respect to t here. So dA by dt becomes x and y both are functions here. So let us apply the product rule. So first function into derivative of the second plus second function into derivative of the first. Now let us apply the values. So what is x? X is 8, y is 6, dx by dt is minus 5, dy by dt is 4. So we will apply 8 into 4 plus 6 into minus 5. So when you apply this, you get dA by dt is equal to, so 32 minus 30, which is equal to 2 centimeter square per minute. Why we are writing square here? Because area is always expressed in square units. That is why here 2 centimeter square minute. And hence here the area is increasing with 2 centimeter square per minute. That is at the rate of 2 centimeter square per minute. So this is how we will calculate the rate of change of bodies with the given condition. So the next question here is, if length of rectangle is decreasing at the rate of 3 centimeter per minute and width y is increasing at the rate of 2 centimeter per minute, when x is equal to 10 centimeter and y is equal to 6 centimeter, find the rate of change of perimeter and area of rectangle, as we have done in the previous problem. So rate of change of length, that is dx by dt, is minus 3 centimeter per minute, because they have said you it is decreasing. Next is rate of change of width with respect to time is 2 centimeter per minute, because it is increasing. Next we have to calculate dP by dt as well as dA by dt when x is equal to 10 centimeter and y is equal to 6 centimeter. We have to find dP by dt and dA by dt. So let's calculate. Perimeter is 2x plus 2y. So dP by dt is equal to 2 into dx by dt plus 2 into dy by dt. So dP by dt is equal to 2 into minus 3 plus 2 into 2, which is minus 6 plus 4. So therefore dp by dt here is minus 2 centimeter per minute. So therefore the perimeter is decreasing at the rate of 2 centimeter per minute. Next is area. We will directly write dA by dt. It will be x into dy by dt plus y into dx by dt. Because the area is x into y, applying the product rule. So now dA by dt is equal to 10 into dy by dt is 2 plus y is 6, dx by dt is minus 3. So here it is 20 minus 18. So therefore dA by dt is equal to 2 centimeter square per minute. Thus the area is increasing at the rate of 2 centimeter square per minute. Next question we have here. A ladder of 24 feet long leans against a vertical wall. The lower end is moving away at the rate of 3 feet per second. Find the rate at which the top of the ladder is moving downwards if its foot is 8 feet from the wall. So here is a wall and we have a 24 feet long ladder which is leaning against a wall. So this is the bottom. So whenever you move the ladder this side, so the ladder comes downwards here. So that means the height of the wall gets decreasing here. That is the height whenever you move the ladder away from the foot of the wall, then here the height decreases. So therefore, let me take this as A, B, C and this distance as x and this distance as y. Here the rate of change of the foot of the ladder which is moving away is given, that is 3 feet per second. So that is they have given dx by dt which is 3 feet per second. Remember here also it is given in terms of seconds, so therefore we are deriving with respect to t only. And we have to find the rate of change of top of the ladder. So this top of the ladder is moving downwards, so we have to find at what rate it is moving downwards whenever x is equal to 8 centimeter. Whenever the length x or the foot of the ladder is exactly 8 centimeter away from the wall here. So now you can see it's a right angle triangle. So now you can clearly see here it's a right angle triangle. So using Pythagoras property we can clearly write x square plus y square is equal to 24 square. Now here x square is 8 square. So 8 square plus y square is equal to 576 we get, or we get y square is equal to 576 minus 64 which is equal to 512. So y is equal to square root of 512. So we can write this as 16 root 2. So take only positive quantities, see, because y is a distance. So distance is always positive. So even though it is under the square root, you can write it as a positive. So now we got y is equal to 16 root 2 here. So now we have to find out dy by dt. So using the same relation here, let me take the same relation. So when you derive it, so derivative of x square is 2x into dx by dt, because we have to derive it with respect to t, write dx by dt. Similarly, y square is 2y into dy by dt, and 24 square is a constant, so therefore it is 0. And when you divide the equation completely by 2, 2 get cancels, so therefore it is x into dx by dt plus y into dy by dt is equal to 0. Now what is x? X we have as 8 centimeter and dx by dt is given, that is 3 feet per second. So it is 3, and y we have got it as 16 root 2. We need to calculate dy by dt. So solving this we get dy by dt is equal to, so when you shift towards that side, so you will get it as minus 8 3s are 24, and when you divide this, here you will get 16 root 2. Again you can cancel this. So we get 4 4s are 16, 4 6 are 24, 2 2s are 2 3s are. So you will get it as minus 3 by 2 root 2. So to remove the denominator another root 2, you can multiply root 2. So dy by dt, you will get it as here when you multiply root 2 minus 3 root 2 divided by 4. So what is this? It is the top of the ladder moving downwards here. So at the rate of how many feet per second here? So minus indicates it is moving downwards. So therefore this is feet per second. So thus using the Pythagoras formula we can calculate what is y, and differentiating equation 1 we can find the top of the ladder moving downwards at the rate of 3 root 2 by 4 feet per second. Next one. A ladder 5 meter long is leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 meter per second. How fast is its height of the wall decreasing when the foot of the ladder is 4 meter away from the wall? It is same as the top of the ladder moving downwards or the height of the wall decreasing here also. So we have the same right angle. The ladder is 5 meter. So here and x, we take this as x and we take this as y. Now again using the same formula we get the equation x square plus y square is equal to 5 square. Let me take it as equation 1. What is given here? So that is the change of the ladder when it is moving away from the wall is given. That is dx by dt is given. That is how many meter per second? 2 meter per second. And we need to find out the height of the wall decreasing when x is equal to 4 meter. When x is equal to 4 meter. Now given x is equal to 4 meter, substitute here 4 square plus y square is equal to 5 square. We get y square is equal to 25 minus 16, 9. So therefore y is equal to 3 meter per second. Now we got y is equal to 3 meter per second. So now we will differentiating equation 1. We get the same 2x into dx by dt plus 2y into dy by dt is equal to 0 here. Again dividing by 2 we get x into dx by dt plus y into dy by dt is equal to 0 here. So what is the value of x? X is 4 meter. Dx by dt is given as 2 meter. Y you have got it as 3 meter. You have to calculate dy by dt. So on solving this we get dy by dt. When you shift here 4 2s are 8, it is minus 8. It comes to the denominator meter per second. So therefore the height of the wall or the foot of the ladder is coming downwards at the rate of 8 by 3 meter per second. Since the height is decreasing, here the sign is negative. Next question. A particle moves along the curve 6y is equal to x cube plus 2. Find the points on the curve at which y coordinate is changing 8 times as fast as the x coordinate. So here the equation is given and the relation between the y coordinate changing with respect to x coordinate is given. So therefore here dy by dt is equal to 8 times dx by dt. Now the equation is given here 6y is equal to x cube plus 2. Let us derive this with respect to t. Then this implies 6 into dy by dt. Derivative of x cube is 3x square. With respect to t means it is dx by dt. And derivative of 2 is a constant which becomes 0. Now we have dy by dt is 8 times dx by dt. Substitute here 6 into 8 times dx by dt is equal to 3x square dx by dt. Both sides we can cancel dx by dt, dx by dt. 3 1s are 3 2s are. So here 8 2s are 16 and this side we have x square. Now since x is a point, it can be both positive and negative. So therefore x is equal to plus or minus 4. Now we have the equation that is 6y is equal to x cube plus 2. So this is the equation we have. So now we'll see the point. When x is equal to 4, so this becomes 6y is equal to 4 cube. It is 64 plus 2. So here we have, this implies y is equal to, so this is 66 by 6. So when you cancel this, you will get it as 11. So now, therefore, the point is 4, 11. Or when x is equal to minus 4. So what happens? 6y is equal to minus 4 is minus 64 plus 2. So this implies minus 64 plus 2 means y is equal to minus 62 divided by 6. So when you divide it, it becomes 2 3s are, 2 1s are, and here it is 2 3s are. So therefore the point here is minus 4, minus 31 by 3. So these are the 2 points. So therefore, considering x is equal to plus 4, you will get y is equal to 11. When you consider x is equal to minus 4, you will get y as minus 31.3. So these are the points at which the curve y coordinate is 8 times the x coordinate. Next question. A sand is pouring from a pipe at the rate of 12 centimeter per second. The falling sand form a cone on the ground in such a way that the height of the cone is always 1/6 of the height of the radius. How fast is the height of the sand cone is increasing when the height is 4 centimeter? So remember, we are completely discussing about a cone here, and we should remember what is the volume of a cone. So the volume of a cone is given by 1 by 3 pi r square h. Now what is given? The sand is pouring from the pipe at the rate of 12 centimeter cube per second. That means the volume, change in volume is given, that is 12 centimeter cube per second. So volume is always denoted in cubic units, therefore it is 12 centimeter cube per second. Next it is given that, so the height of the cone is always 1/6 the radius, that is h is equal to 1 by 6th r, or you can take r is equal to 6h. Now what we have to calculate? How fast height of the sand cone is increasing. That is change in height with respect to time we have to calculate whenever h is equal to how many centimeter? 4 centimeter. So these are the things given. Change in volume is given. Relation between height and radius is given. And have to calculate the change in height whenever height is 4 centimeter. So now let us derive this with respect to t here. But before this, let us convert r in terms of h. So here it becomes v is equal to 1 by 3 pi. R is nothing but 6h. So therefore it is 6h whole square into h. So v is equal to 1 by 3 pi into 36 into h cube. We can cancel here 3 1s are, 3 1s are, 3 2s are. So therefore we get volume is equal to 12 pi h cube. So see here, it is 12 into 1, 12 pi h cube. Now let us derive it with respect to t. So when you derive it with respect to t, it is dv by dt. 12 pi is constant. H cube is nothing but 3h square into dh by dt, because we are deriving the quantities with respect to t. Now next we have here dv by dt is given as 12. Next 12 into pi, 3 into h is given, which is 4 square. So 4 square means it is 16 dh by dt. Now 12 cancel, 16 3s are 48. So therefore I can write dh by dt is equal to, so this complete thing can be moved to the denominator, 1 divided by 48 pi. So what is the unit given here? It is centimeter. Since this is height, we can write it as centimeter per second. So therefore the height of the cone is increasing at the rate of 1 by 48 pi centimeter per second. Next one. The radius of a circle is increasing uniformly at the rate of 3 cm per second. Find the rate at which the area of the circle is increasing when the radius is 10 cm. So, change in radius with respect to time is given, which is 3 cm per second. Now, change in area with respect to time has to be calculated whenever radius is 10 cm. We know the formula of circle, that is area is equal to pi r square. Derive it with respect to t. So, it is dA by dt is equal to pi. R square is nothing but 2r into dr by dt. Now, substitute the values here. So, dA by dt is equal to pi into 2 into r is 10 centimeter, dr by dt is 3 centimeter. So, 10 into 3 we get. So, therefore, the area is changing at the rate of 60 pi centimeter square per second. So, this is the change in the area of a circle. Next question. The volume of a cube is increasing at the rate of 9 cubic centimeters per second. How fast is the surface area increasing when the length of an edge is 10 centimeter? So, here the change in volume of a cube with respect to time is given, that is 9 cubic centimeter per second. We have to calculate the change in surface area when. So, whenever the length of an edge, so that is L is equal to 10 centimeter. We know that volume of a cube is L cube. Now, let us derive it with respect to t here. So, this becomes dV by dt is equal to 3 into L square into dL by dt. So, now here dV by dt is given, that is 9. 9 is equal to 3 into L square into dL by dt. Now, 3 ones are 3 threes are. So, therefore, dL by dt can be written as, so 3 by L square. Take this as equation 1. Now, we know the total surface area of a cube is 6 times L square. So, if you take dA by dt, then this is 6 into 2L into dL by dt. Now, here dA by dt we have to calculate, that is change in area with respect to time. So, here dL by dt can be written as 3 divided by L square. So, here L get cancels. So, 6 2s are 12, 12 3s are 36 we have divided by L. And the length is given, that is 10 centimeter. So, clearly we can write 36 by 10. So, therefore, area is 3.6 centimeter square per second. From the volume, we can find out the change in length and substituting the change in length here. So, here also you can substitute L square as 100 where it becomes 0.03, and then also you can substitute, you will get the same answer, or just keeping the equation and substituting also you will get the same answer. So, from the volume we will find out the change in length. So, using the change in length we can find the change in area of a cube with respect to time here, which is 3.6 centimeter per second. So, these are all the questions from rate of change of quantities, which will be 5 marks, which is very important for your exam. We'll meet you with one more application of derivative in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.